Okay, so now we're going to go down 3, which we did. Now, you have to understand, this number back here, this controlled the up, down, right, left. That's a down 3. Now we're back to this. It's the parent all over again. Just do what the parent does. What does the parent do, though? From the vertex, right 1, up 1. Right 2,
Up 4.
right 3,
Up 9.
5, 6, 7, 8, 9. Can you see the right side of your U? Well, on the left side of your U, it's the same thing. Now, you guys can mirror this across. When you mirror it across, what's it called?
Mirror.
No, there's a word.
Reflecting.
Close.
Transformation.
Okay.
Translation.
Symmetry. Parabolas are symmetrical, so you can mirror them across. This point would just go right about there. This point, here. So you don't have to sit there and go left 1, up 1, left 2, up 4, left 3, up 9. You can kind of just right about, you can kind of almost look at it and say that's where it is. Okay, now there's your new parabola, right? And maybe label it, this is my parent down 3. Just label it, x squared minus 3. Okay? All right, that one's done. Did you notice? What didn't I do?
Make a table.
I didn't make a table. You guys should be happy because I could make you do tables, and it wouldn't be fun because you'd have to work all these problems out. You wouldn't want to do that. I don't think. Okay, this one. Do you recognize it as your quadratic function? Why? It's x with what on the outside?
Squared.
It's x squared. This is the quadratic function. It's the u again. It's just that it's been moved which way?
Left.
Okay, so when it's inside grouping symbols, and you see a plus 5, your mind probably says plus 5 is right 5. It's the opposite. It's which way?
Left 5.
Left 5. This is weird. It is. It's weird. For you to really understand it, we would have to make a table and show that it really does work. We're not going to because we saw it work yesterday. So this one's going to go left 5. So where would you go with your vertex? Now remember the old parent function? The vertex is right here. Where would you go with it? Left 5. So where are you going to end up?
Left 5.
Right there at -5, right? Now you've already taken care of this, guys. Look, this is done. You already went left 5. Now you have x squared. That's the parent. What do? Parent acts the same way.
Up 1. Up 4.
Right 1,
Yeah.
up 1. Right 2,
Up 4.
right 3, up 9. Okay, right there. And if you're good at this, you'll just mirror it across. There goes. Okay. So now, what question in the back, John?
What?
You okay?
Yeah.
Okay. Sounds like you have questions. No?
I'm good.
Okay. So what makes it go right and left?
The parentheses.
Anything inside, you know what, I can say parentheses or I can say grouping symbol. I'd rather say inside the grouping symbols is right and left. On the back side, anything on the back side is up and down. Okay? If you see on the back side, you see a minus, it's down. If you see a plus, it's up. Okay, questions? Are there more questions down there?
Yes.
Yes, okay. So let's go down and see what we got. Oh, state the what?
Parent function.
Okay, the parent function is, which one did you have? The absolute value, the quadratic, did you have cubic? Quadratic. So we had a quadratic parent. Okay, so quadratic parent, y equals what? X squared, right? That's the family we were copying, right? Mark and describe the transformations. I already did it. Look, left 5. Up there I wrote what? Down.
Yeah, down 3.
3, okay. So this one's done. State the what?
Vertex.
Vertex of the transformation graph. The one you transformed right, left, up, down.
0, 0.
You have to say what on this one? What's the vertex?
Oh.
-5, 0. Okay. What's the vertex on the one up there?
It's 0, -3.
Yep, 0, -3. Okay, so they're going to ask these questions on your homework today. So I thought, well, let's just put the same questions on there. So here's your transformation. You took your parent, went down 3. Your new vertex is 0, -3. Same thing here. Okay? That's the quadratic family. What's coming next? Absolute value family. Okay, graph it. This is the parent, by the way. Just graph it.
Are you gonna have us do the linear parent? Too?
No, I didn't say that. The linear parent. Do you know why we don't really transform the linear ones?
It's simple.
It's very simple. It's just a line. You can pick out the slope, you can pick out the y-intercept, you can graph it pretty easy. That one we don't get into much, the line, the linear one, just so you know. But it works. We're just not going to do it. If you've got a good memory, you're done with this already. If you don't, guess what? Make a table. Is John the only one that wasn't here yesterday? Okay. Somebody tell John, what's the definition of the absolute value? What's it asking?
What is the distance from 0?
What's the distance from 0? So how far is 0 away from 0?
0.
How far is 1 away from 0?
1.
2. How far is -1?
Because distance is always positive.
Yeah.
John.
Distance is always positive. Okay, so
I
2.
understand that.
Got it.
Okay, I was just
Here we go.
okay.
Graph it. Did you graph it already?
Sure.
0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, right? On the back side, -1, 1, -2, 2, -3, 3. Do you notice that both sides of the V are just lines? So really it's like a linear equation shooting this way and a linear equation shooting this way. So it's 2 lines meeting up. It's a V. Absolute values are always V's, where quadratic is always a what?
Parabola.
It's a U. It's a parabola. Yeah. Okay. So now, let's do this. What's the vertex? Let's get this one. Vertex is the lowest point of the graph.
0.
Okay. All right. This question goes with this question. Describe the behavior. Explain the right and the left sides of the vertex. So when you describe the left side and the right side of the vertex, you'd say, on the right side of the vertex, it's what? Right 1, up 1. Right 2, up 2.
Can we just write the slope, or is that not allowed?
Can you what?
Can we just write the slope as 1?
Not yet. I'm getting there. You're just a little too far ahead. That'll be more Wednesday and Thursday. Okay, right 2, up 2, and you can keep this going. It's right 3, what? Up 3, right 4, up 4, right 5, up 5. Okay, on the left side, it's what? Left 1, up 1. Yep, left 2, up 2. I think I'll stop there, guys. Because the pattern's pretty easy. Okay, now the pattern's so important to you because you have to know everything we do in here is just that parent doing this. That's all it's doing. But the shape of it never what? It never changes. Well, I shouldn't say that because it's going to change tomorrow. But we won't talk about that right now. Okay? Here we go. Graph it. See if you can do it without my help.
If I have a graph, go from the water bottle.
You know, we did this yesterday on the calculator, so hopefully you kind of understand why that's happening.
Okay, I don't know.
And if you really, really want to know, make a table. The table will tell the story.
Okay, I don't know water bottle.
No, not right now. As soon as I get done here, yes. Okay?
Bless you.
Bless you.
Okay. Now, inside grouping symbols. I don't care if it's parentheses, I don't care if it's brackets, I don't care if it's absolute value symbols. Inside is a what kind of transformation?
Opposite. Weird.
Well, I know, but
Left and right.
left and right.
Oh,
That's really all I wanted you to say. But now when you look inside, you go, a -3 seems backwards, doesn't it?
Yep.
It's not. What is it? That's a right 3. Okay, followed by, the number on the backside of your function is up and down, it's vertical, up, down. Which one? -5? Exactly what you think on the backside. Down 5. So, if you gotta take that whole picture and shift it, okay, now, what, that whole picture, remember that V? Which point would you grab first? Vertex. You'd shift it right 3, down 5. So here's the vertex 0, 0, 1, 2, 3, 1, 2, 3, 4, 5. Isn't that your new vertex? Yeah. And now you should know, we took care of this, we took care of this, now we have the parent. That's all that's left. Tell me what to do. Right 1 up 1.
Right 2,
Right 3 up
3.
3. There it goes. Okay, right? Correct, any?
Yeah.
Okay, on the left side, you just do what?
Mirror it.
You can mirror it, left 1 up 1, left 2 up 2, left 3 up 3. There you go. That's it. You okay with that? All right. It's not hard to slide the vertex around, but you've got to know what the -3 meant, and you've got to know what the -5 meant. Okay? If you don't know, you're just guessing, and your parabola, or not your parabola, your absolute value will end up over here, over there, and it's not supposed to be. Okay? Oh, we have questions about this, don't we? Read them to me. The first question is,
State the parent function.
okay, what's the parent function?
Absolute.
Absolute value.
Absolute value. You might as well write it. Y equals what?
Absolute value is x.
Yep, that's the parent, right? Write that down for the first question. Second question was?
Marked it and describe transformation.
Oh, describe the transformation. That's easy. Right 3, down 5. What's the next question?
State the vertex of the transformation graph.
Okay, so once I transform the parent this way, what's the vertex?
3, -5.
Vertex, 3, -5. Got it, done. Good?
Perfect.
See, you guys listen so well. This is making sense. So that's a good thing about you guys. You listened well yesterday. Now, this one, what function am I in now? What family? Cubic, x cubed. I'm not going to say it. Just do it. You go do it now. If you have no memory of yesterday, guess what?
Table.
Make a table. Keep putting numbers in. 0 cubed is what? 1 cubed. 2 cubed.
8.
-1 cubed.
-8. Or -1, yeah.
-1. -2 cubed.
-8.
Okay. So that's what you and I actually did this yesterday. We actually did all that. But then we said, memorize it. Okay? Now, graph it. Here we go. 0, 0. 1, 1. 2, 8. -1, -1. -2, -8.
Huh.
If you connect them, it's nice and smooth, and then it just keeps going straight up and straight down. And I shouldn't say straight up, because it does keep moving which way? Still keeps, it goes up and up and up, but it's always moving right. This one's going down, 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 but it's always moving left. Okay, so it does spread all the way out there and there, but it goes down and up. Okay, so there's a little sway going on, right? When that little, it looks like it's going up, 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 and then it looks like it's gonna do this, turning down. But it doesn't. It goes up, 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 and then it hits, and then it goes back up. So I'll call that a pivotal point, not the vertex. There is no vertex to this, because a vertex is the highest or lowest point on the graph. You don't have that. So put what here? Pivotal point. What's the pivot point? What would you guys call the pivot point? 0, 0. Yeah. At 0, 0, it looks like it's going to turn and go down or turn and go up. It doesn't. It goes through 0, 0 and keeps going down or up. Okay. Here we go. Describe the end behavior on the right and the left side of the pivot point. Okay. I got some paper in here. I'm almost done with the notes though. Oh, that's right. I ran out. So here it is. There. We are actually, we're right here and we're going here next. Okay, guys, describe these behaviors. That's the pivotal point right here. So that pivotal point, when you move one right, where does the cubic function go? Up 1, 2 right,
Up 8.
up 8. Just write that down. So when I go right 1 and I go right 2, I'm going to go up 1, up 8. You okay with that? But on the left side of the pivotal point, we're going to go what?
Down
Left 1,
or left 1 down 1.
left 2,
Down 8.
down 8. There you go. Left 1, left 2, down 1, down 8. Okay. Good. That's who. Who does that? What function does it? The parent. You're supposed to say parent. The parent does that. Now, what makes the parent change its look? Transformations. If I add numbers and subtract numbers, you're going to get different looks. There's a different look. Try graph that one. Okay. Give you 30 seconds. Go. These two numbers are doing something to your parent. Ranson, the -3 did what to the parent?
Moved it right 3.
Okay, Ranson says it moved it right 3. Would you agree with him or not?
Yes.
Yeah.
Even though it says -3, it's backwards. But it's inside parentheses, so think what? Opposite. It's forward. He's right. You got it right. Branson, finish it. -5 in the back. Down 5. On the back side, whatever it says, believe. I mean, minus means down, plus means up. It's very simple. Follow what it says. Inside grouping symbols do the opposite of what you think. Okay? Yes, John.
I know this might be getting a bit ahead of myself, but when it comes to all these parent functions, what happens if you do it like to the 4th power?
You're into a different function. That's not.
I'm
That's a different family. And yesterday I talked about 4 families: x squared, x to the first, x to the second, x to the third. Didn't talk about x to the 4th. That's pre-calculus. We'll get into that next year. You sign up for my class next year. We can talk all day long about x to the 4th.
See you there.
Yep. Okay, guys, this is not a vertex. This is a pivotal point. It's where it does its little swing. Okay, so right 3 down 5.
3 -5.
Right there. Right.
Mm-hmm.
Okay, that is the old 0, 0 pivotal point on the parent. Now just do, you guys, you already took care of this. You already took care of this. You have what left?
X to the third.
X to the third. You have the parent. Let's do what the parent does. Parent does what? Right 1,
Up 1.
right 2,
Up 8.
2, 3, 4, 5, 6, 7, 8. And then left 1, down 1, left 2. I think that's 8. It's actually 6, 7, 8. Okay, so there it is. Go like this, this, this. There it goes, and there it goes. Okay? Did you do that? If you did it, you got it right. Good job. Now, question 1. What family are we in? This is the cubic family. And the parent function is y equals what?
X to the third.
X cubed, comma. Next would be give me the transformations. Okay? Next would be what? The pivotal point, right? What's the pivotal point? 3, negative 5. It's called a pivot point because it is not a vertex. A vertex is the lowest point on the graph. It's not. We're going to call it the pivotal point. Where there's what? Kind of makes its little sway right about there. Okay? I'm done. Unless you have a question. We're good? So who are you? Are you this guy? Are you a 1? I don't get it. You're about ready to cry. Are you a 2? I kind of get it. Thinking about it. Are you 3? Do you really get it? You know you have it. Or are you a 4? You can teach it. I can give my pen up to you right now. Here you go. You want to teach it? Are you a 4? Give me numbers. I want to see where you're at before I turn you loose. Ready? I'd say your average score in this class is probably 3. We have 4s in here. There's people that think they can teach it. Okay, that's great. We have 2s in here though. We have 2, so I'll try to catch up with you. Here it is, your assignment. You see those first 3? That's the parent functions. You can graph that in 10 seconds. But it does say make a table. It does say it. Just do it. Then down here, don't make any tables. Just slide your parent and graph it. Here's your graph paper, okay?
So we're not air hands on the word.
Oh, we gotta go up.
Here we go. I know, but I don't like the book in this one, so. I just don't like the book. The book does a terrible job with this.
You don't want to
You don't have to bring it tomorrow. Okay, for sure tomorrow. But you might have to bring it Thursday. Here comes some graph paper. You don't need graph paper until you get to letter A. Okay? Which will be in about 2 minutes.
That's one fancy test sharpener there. It's pretty nice.
Yeah, I know. Cost them a minute.
Yeah.
Okay, so she's kind of
Say thanks to your mom and dad.
triple D.
Oh, they didn't pay for it.
Yeah, they pay taxes.
Oh, they don't.
Triple D, but not a D.
The graph paper's coming.
Thank you.
You need some?
No.
No.
I'll just take it.
Okay.
Thank you.
Okay. All right. You guys, you said there were 3s and 4s and a couple 2s out there. I'll try to catch up with the 2s. Otherwise, you just work. I'm going to pass back your quiz. Okay. Just a quick comment about your quiz. If it wasn't good, you don't like it, you can always come in after school. We can talk about it. We can redo a few problems. Are you listening? And if you don't like it, you can redo it, but it's not free. You have to put in some time after school, okay? I don't just give a makeup quiz because I know the score will be this is bad. You got to practice with me, Okay? Alright. But you gotta come in after school too. Alright. Anytime you see a half a point, let's say you get 27 and a half, in my book, it goes 28. So I do round up. Oh, sorry, Mom.
Yep.
Is it Taylor or Tyler? Taylor, okay, sorry. Diana what? Medru, DR.
So if any,
It is DR. Medru. Diana? Diana. Be right there, Cap. Easy. You don't want these? Why? Oh, yeah. You should look at it. Much harder.
we have to watch that.
Oh, yeah.
Rabbi today. You are.
Like this one. So what happens?
You're basically like being crabby.
Because that has exactly the interaction needs. So,
I don't want to like start off my answer. Yeah, shrug your shoulders. You have no way to get yourself
You know what? I'm gonna try.
You're in
Okay. Hey, I need a favor. Who takes notes and does a pretty good job of writing everything down? I need to explain it to her because I just don't have anything right now. Anybody?
I do.
So, very good. When it comes to X squared, it is 0, 0, 1, 1, 2, 2. Explain the right. And if we did right 3, squared 1. That's what she said. And then on the other side, it's 2, 3, and that's what she proposed. Then over here, what happens is, anytime you take x squared, add a number, subtract a number. That's going to be this picture. Drop it. So 0, 0, 1. Well, 0, 1. And then from there, which is that, these are called transformations. You just take the pairs, slide it over, slide it.
I think the first
And
one.
then you do this.
Yeah, it's the same thing.
That's the square is. It's the u, that's the problem. Plus 5 means you
Yeah, these are pretty easy. You just have to do the opposite of what you think.
So when inside Wednesday, they're gonna go right or left. Go ahead.
I didn't know
Where
if
it
there
says
was
plus,
one
they're gonna go left. If they would have said minus five, they're gonna go left. So she does, she goes left. So she takes 0, 0, and she goes left. And then she does all those. Then we did it again with the line functions. Oh, sorry, state the one page, just two lines. Mark and describe the transformation. Down 3. State that. The new version, what's the new one? 3, what's the new one here?
I got
Then we go to this. So you did see this. The absolute value. If you can't remember, you gotta make a table. And so you go here. So what happens is, basically, it's 1, 2, 3, 4. So how do you explain the right from the vertex you go like this, 1, 2, 3, or left one. Minus we see backwards. Minus 5 is so she goes from the forward. Right? Yeah, yeah, you were making tables and that's what I said right away. Don't make tables. You were gonna make such a mess. Here's the cubic. You remember that? So 0 goes in, 1 goes in, 1 goes out, 2 goes in, 8. So she says, when you, from the pivotal point, if you move 1 to the right, you go up. You go 2 to the right, you go up. No, 8. See, in this one, when we made a table, we put some numbers in. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. Negative 1 is cubed, it's yours. Yeah, so
You don't gotta do it.
left 2. Yeah. So this is what she said. When you go left 1, you go down 1. You go left 2. And where are we basing this on? The pivot. Not called the verb.
My teacher had my.
It's called the pivot. Because really, it's almost looks like it's going to be keep going.
So by answering them,
From the
associate
pivot.
them.
No, they catch themselves after I answer.
This is
Just say, one time, that's what Welsh does.
so what are we doing?
Yes.
It's right here. How come? This is what? So she goes right here now, but she ends up right there. And then she does all this. You think you can do it?
Actually, the last
Sure.
three of us were all there.
Alright.
Grace,
Okay, thank you. Alright, did I finish giving the quizzes back?
No.
No, I did not. Okay, sorry. Oh no, this isn't it. Where did I leave them? Oh, right here. Right here. Okay, here we go. And Maddie, Belgard gone, Ellie. Elizabeth, Lewis, Maddie's gone, Lewis, Who else is on?
Did they die or what?
And you need them back, do not run out. Do not run out of the room with them.
Where do you want it?
Yeah, grab all. Grab. It says right here.
Say to grab.
Where is it? I can pick
Oh.
it.
Grab.
And this one.
Okay, so the word
I know I got.
graph. Okay, so section 2, the word graph never really shows up in the directions. Graph.
Oh, good, so to say.
You actually have to figure it out without graphing it. Actually, it's you figure.
Oh, yeah. Okay. Chris? Quizzes, thank you.
Why do you want John?
Okay. Did I tell you the halves round up on here? Okay. I round halves up. I don't want to put 25 in the computer. It takes too much time. Didn't take it.
Well, my
Six more problems. I would actually just figure it out right here. It's not hard. That one's built in, cubic, so that'd be 0. You don't need graph. You're supposed to, you get all the information. I mean,
I want you to that's expert.
I mean, if I wanted to, I could have. Maybe Thursday. Yeah. Thanks, guys.
so what do you, place in that?
my regular heat sink is a bit of a gas, right? And,
Anything else or?
No.
That's fine.
That's
I'm
fine.
planning on upgrading.
What I would have done is I would have you probably did. I would have done if it's up,
Plan on,
then I would have.
yeah, that's about it. I also plan on upgrading this to a water
Then I would have
system,
done.
and then upgrading my processor to an overclock one, and that should be fine.
Then I would have veered it over. Veered it over.
Exactly the same price.
Yeah, I don't understand why you're not going down in price.
Yeah.
So now, here's what I would.
The 1060 is better than a Titan
Alright.
X.
You serious?
Yes.
Yeah, I mean, that's what
The
you,
1060
exactly.
is better than a
Where,
Titan X.
this is cheaper, right? Well,
The 1080
I mean,
is
relative.
you never go the other way.
I mean,
If I go left, I go up. If I go left too, I go what? No, okay? So you just do what this parent does. Good? Come in after school, let me help you, okay? I mean, if you feel a little lost. just a minute. I think you guys are in the computer lab.
I actually wanted to ask you a question. What do the fourth power versions of that?
You wanna know? You wanna really know?
I'm curious, you know. I don't know what's happening, but my brain is like hyperactive.
Hyperactive. I think you're in the computer lab. I think your classes.
Okay,
You grade 7?
Yep.
Yeah, she's in the computer lab.
Downstairs.
No, computer lab is just down the hall. Just go down this hall halfway to the right.
Yeah,
About 50 yards. So you're saying what's gonna happen here?
Yeah.
X to the fourth, if you put 0 in, you get what?
Zero.
If you put 1 in, you get what? If you put 2 in.
We get 2 times 2 is 4, times 2 is 8, times 2 is 16.
Okay, if you put 3 in, 3 to the fourth is
That'll be like 60,
3,
70.
9, 27, 81. Okay, so what happens is you get this look, 0, 0, and then you get all the way up to 81. So if that's 81, 381 is right here, 216 is about here, 1 is here. And on the back side, when you do -1, raise it to the fourth power, you still get this number 1. So really, it just gets mirrored across.
No, like when we did the, I forgot what it was exactly called, but I was talking about like, one of the options it was like did this and then it went like this and then it went
Well, that's the cubic function, yeah.
So
That's the.
So why is there a difference between the cubic and the?
This is an odd function. This is an even function.
So the fifth would
Evens,
just be.
evens go like this, up, up,
All right.
and odds do this, up,
So
down.
can I see something?
Yeah.
So what happens if like the function of x is equal to the absolute value of x, I don't know, -1 to the third power or something like that?
Well, here's the deal. Whatever, yeah, I gotta do this. It's a finicky little thing. Put that here. Okay, whatever comes out of this right here, absolute value, what kind of numbers come out? Now, the girl next to you said it's the distance from that
0, yeah,
that number to 0. So when only distance is always what?
positive.
So when you cube a positive, you'll always get a positive. So what's going to happen is you're still going to get your V. You're still
It'll
going to.
just be like.
It will just go instead of normal V like this. This would be like the parent. That's the parent. But because you're cubing it, it's just going to go faster. It's going to go
All right,
up,
so
up.
the higher the exponent, the
Yeah, the more narrow it
yeah.
gets. And those are all things we're still going to talk about, but you're just getting way ahead of me.
Oh,
I'm just trying to teach the basics. And you're looking for more stuff. Hey, where are you going? Why'd you take it with me? Oh no, you took it. I'm sorry. I'm sorry.
Hello.
Well, hello, you two. How you doing?
Good.
Just tripped. I'm doing pretty good.
I want to know because I was given this thing, and apparently they thought that I was supposed to graph these on here, but there's graphs there.
No,
so-
no. Okay, these you graph by making a table, graph it. You did it. Now down here, period 6 told me the word graph never showed up. Like it doesn't say to graph these, but I wanted you to graph
That's
these.
what I was gonna ask you about.
Yeah. I know the word graph didn't show up. Sorry.
So he had to grab.
But how do I? But where do I?
What?
Mark and describe.
Well, like-
what's mark? The mark part.
What do you mean the mark?
What would marking be?
Mark and describe the transformation. The word mark, I'm not sure about that. I think mark just might mean mark it like this way,
And do I have to?
5,
But I-
like
do I
right
have-
5, like that.
Like, would I have to write the right, left, up, down
Mhm,
words
mhm.
on here and not there?
I would write all your information right here and then graph it there. So like here, if we did letter A.
I mean, how can you mark it on there?
Well, let's just try this. Ready? State the parent function. Is A linear, quadratic?
Quadratic.
Okay, so it's quadratic, right?
Mm-hmm.
So you can say quadratic. You could have said there. That's the parent. Okay.
Yeah.
Okay. B. B says mark and describe. Well, mark to me, mark could be like right. I could draw an arrow. 5 units. Like just tell me. Right 5, left 5, up 5, down 5. What do you think?
It's down to.
Down 2? Okay. Anytime you see a function, any parent with something on the backside, you have a +2, don't you? Now +2 on the backside means,
I read it as -2.
oh, okay, well then you were right, but it isn't, it's +2, so it's up 2. Okay, C, what's the new vertex?
Wait, I'm not doing B.
No, we're still on A, and I'm doing, now these are numbered. This is kind of weird. These are numbered, not lettered. So we would say 1, 2, 3. Okay. So number 3 says state the vertex of this new one.
0, -2.
0, 2. And it would be probably much easier if you would graph it first and then answer these questions. Because once you graph it, you'll know it's quadratic. You'll know.
Like, is the graphing part actually required anyway?
Oh yeah, yeah. That's why I give you the 12 grids. Because you have 12 graphs.
Do you understand?
Yeah.
Yeah.
Do you have any other questions?
No. How about this? What if it would have instead of saying x squared plus 2? What if it said this?
That's to the left.
2 to the left. Okay. Yep. Opposite. It's the opposite of what you think, right?
Way over my head.
Well, you weren't in here either. So, but it basically inside groupings, anything inside.
It's opposite.
If it's that,
It's +5.
that's right 5. The whole graph
Or
goes
right 5,
right
okay.
5. And and then she has to always be looking. Is it the quadratic? Is it the U? Or is it the cubic? What's the cubic?
Upside down.
It's actually like a little wave, and like there's called a pivotal point.
Actually, I was just thinking, like, the linear one and the absolute value one are opposites. Are sort of opposites as these. The quadral and cubic ones are sort of opposites. Like if you could do, like you could make another one of those.
You could do like
lower.
this, like that.
Yeah, and it
Yeah.
would be 2.
That will be coming tomorrow. That's tomorrow. But today
And
we
then the same.
Today we didn't talk about that. Today all we talked about today was right, left, up, or down. And the picture never changes. Okay? Here's the quadratic, here's the absolute value, and here's the cubic, right? So these 3 graphs, all they're gonna do is shift up, down, right, or left. And then you always look for that. This is like your starting point, and it's always 0, 0, by the way.
Okay.
It's always 0, 0. So these points just get slid around.
Alright.
And then you just draw the same picture over and over and over.
Just a different.
Just in different spots. Yep. So
Sound good?
I think she's got it. It sounds like she.
How did the quiz go and everything? Did you get a chance to read it?
I'm trying to think if I even got to hers.
If not, it's not a big deal.
I think she got like 29. I don't, 29 out of 31. And Nelson. Oh, why did I write it in there? I just put it away in the file cabinet. I think she got 29 out of 31.
Okay. There's no way that they're legitimately wrong. What I mean by that is me actually misunderstanding what they're asking me. If I got it wrong, I feel like there's absolutely no way I didn't read a plus as a minus or something.
Are you talking about the quiz?
Yeah,
Oh.
that's a better way to get something wrong than legitimately not understand what's going
But
on.
a 29 is still a
No, it's really a good score.
I know, but I want to know what happened. I
Oh,
want to know.
I don't blame you. I don't blame you at all. Let's see. What happened? What, okay, X. Period 5, right? Aren't you period 5?
Yeah.
Yeah. Okay, so period 5. Either
Yeah,
percent.
I'm especially concerned that someone else in this class probably did get a 31 out of 31. Does make it me look more stupid.
You're not stupid.
No.
As
You don't want to
in the
compare,
great
don't
scale
compare
of
yourself
things.
to anybody else. Just worry about Hannah. Here we go. No, Hannah's wrong, Hannah. There we go. Yeah, 29. What a memory. Okay, so what happened, here's what happened. You worked this function out
Oh wait,
and got 10, which is right. And then it said write your answer. Your answer 10 is an ordered pair.
oh you didn't like that I.
Oh, we were.
You didn't like that I used a minus.
We didn't
No,
do this
no,
one.
no, no,
Remember,
no.
we were gonna ask and we forgot.
You got a question mark here, it looks like.
Yeah, we were gonna ask and we forgot. So it's not a big deal.
Yeah, it's not a big deal. What it meant was ordered pair just means you put in what number? Negative
Oh,
3.
wait.
-3 for X.
And you got out 10 for Y. So this is called an ordered pair.
Is that-
It's just a point on the graph.
Hold on a minute.
So remember, this is the problem we weren't able to do, but this is your Y, and this is he gives you an X.
Mhm.
So X would be -3, and then your Y we calculated, and that was 10. So remember, we calculated right here, and we got 10 for Y. So then we would just put -3 because he gave us that, and then 10 for Y. But we forgot to do that, so next time we'll have to be more careful, right?
It makes it when you circle all this, it makes it look like you get all of it
No,
wrong.
I'm sorry. I won't do that for you. Lots of times what it is, Hannah, just so you know, there's a lot of writing on your paper.
Oh,
So
wait a
what
minute.
I'm doing is I'm looking for answers.
There's only one minus one, but yet it's a 29 out of 31.
Oh, so you got this one wrong, -1, and then this one too.
But why is there a minus one as a total?
That's my total on this
Per
page. One run on this page.
So for this one,
This one, I think, okay, this minus is a plus, right?
Yeah, and
Okay.
that's I knew that.
Yep, no, I'm just trying to double check, see what happened. This is a
oh,
plus.
did we minus it?
And then you subtract 8.
Well, that's I did it because it was a minus.
Oh,
Okay,
yeah.
now, okay, so now wait a minute. -8. That minus is a positive. Right?
Yeah.
What's -8 times a positive 5?
Maybe.
Yeah. And you put positive 40. And see, that made you think.
I remember
That made you think the answer was plus 32.
that made what I was. That could have been you too, because because you also made a mistake before where you added the 8 instead, and I told you.
It could have been. It could have been.
And I must have not seen that.
So we'll have to be more careful next time, right?
No.
Yep. That's okay. We'll be more careful next time, and I'll make sure I don't put negatives where they don't belong, or positives where they don't belong.
Oh, wait a minute. I think this is for period 7. She's in the computer lab. Pretty sure she is.
Oh, so what was up with this one again?
Nothing, you're right.
You just
That's
circling
good.
this to show us.
That's the answer. The thing is, they said, write your answer as an ordered pair. So in goes -3, out comes 10, which is just a point on your graph.
I mean, because I wrote not possible here.
No, you're going somewhere else now. Stay here. This is exactly what when they say write your answer as an ordered pair, in goes -3, out comes 10. Okay? Down here, I didn't count anything off because you wrote the words not possible, which is, I know, -10 plus 10, you didn't write 0, so I wrote it for you. And you're right, this divided by 0 is not possible.
So it's also all because I didn't write down the rest.
No,
of
it's
it.
not wrong. It's
No,
not
it's
wrong.
not wrong.
It's good. You wrote not
I
possible.
know, but there's 2 minus 1s.
No. Here's -1. The whole page, how many wrong did you get? just one. So I put it on the bottom,
So who knows?
because then I know on this page you have one wrong,
So
on
basically,
this page you have one wrong, which makes two wrong.
so basically, one I got wrong because I didn't do, and the other one I got wrong because I don't.
As an accident negative. So we'll be more careful next
Yeah.
time, okay? It's only
Every single mistake I experienced based on some sort of like writing the
error.
symbol you didn't mean to.
Yeah, it happens.
Yeah.
Which
You
We're
know,
all humans.
people
mistakes happen.
no one ever addresses that as a mistake that people can ever make in math. It's always like, oh, you didn't understand the concept.
Well, you understand them
That's
perfectly.
usually what people talk about.
I know, but you can't understand the concepts. We just made a little typo.
Yep.
And that happens.
Happens all the time. Believe it or not, Hannah, it does.
It's gonna happen forever and ever.
I don't know if you can stop that one.
No, I make typos.
Should I give this back or what?
What is it? Is that the quiz? Yeah, I'll take it.
Oh, do we not have enough time left?
Nope, we have plenty of time, Hannah.
We're less than a half hour.
We'll get there. Thank you.
Yep. Mm-hmm.